If you want to add questions today, there won't really be a big audio chat back and forth or a lot of time for Q&A. Hey there, welcome. But it would be great to open the chat and type in any questions that you might have. And of course, you can reach out to me by email. I'll give you that at the end of the presentation. But I definitely want to hear from you if there are any things that need to be clarified. And with that, I think we should probably just dive right in. I'm going to do a quick review for starters. So the overview for this afternoon includes why now. We're going to go right into the grant and talk about, wow, the tremendous pairing of what California State has put together in the Healthy Soils program and the way that those practices that will be reimbursed dovetail so beautifully with regenerative practices. And this is part of an ongoing discussion amongst the Regenerative Vines Working Group, because we've been exploring the principles for quite a while. We've had a few seminars that some of you have been able to come to. I'm calling them coffee talks. We've heard from Mimi Castile and Steve Mathias, and most recently talking in detail to address people's specific questions about practices and how the principles actually work in the vineyard. But today we're really going to focus on the detailed practices by request. We'll also talk a little bit about who's behind all of this, who are the influencers and researchers that are bringing regenerative strategies to a place where there's true evidence that we're evolving agricultural practice in that long 8,000-year tradition. So we'll take a look at that, and we'll hear from one of those researchers today. And then we'll just talk a little bit during that period about how regenerative ag practice is different, or a beautiful culmination of a lot of what we've seen in forerunning efforts to improve our vineyards. And then finally, we'll just talk about who wants to take action and who feels motivated, what's possible for you, and next steps there. So let's look at the grant right now. The funding for the Healthy Soils program is pretty impressive, and it pairs with a grant that will come online later this season called SWEEP. So that's the State Water Enhancement and Efficiency Program. Some of you are probably familiar with it because it funds upgrades in irrigation. And today we're not going to focus on it, but I want to throw it out there because it's a great thing to keep in mind. Who's paying for all of this? The funding for this grant is coming out of cap and trade, essentially. So this is the California Air and Resource Board and the climate investments component of that board. So all of this money comes from that fund. And that's part of the why of why it's so compelling. California has set some pretty ambitious 2045 net neutrality goals. And in agriculture, that translates to all the bullet points that you see there. Reducing our energy and fuel use, reducing nitrogen fertilizer, soil CO2 sequestration, producing renewable energy on site that serves the farm operation, and reducing methane emissions, of course. And then who are the early adopters here? Cereal growers have really been key in launching this. A lot of that has to do with the image you see right above this portion on the slide, because their capacity for animal integration is very high. And of course, multi-cropping, and then you've got managed grazing. So it's a perfect combination. But internationally, we now see, and heard Mimi Castile talk very eloquently about this, pretty significant global players like General Mills stepping into this process and developing regenerative ag approaches for everything they're doing uniformly across the globe. So it's compelling. It does mildly impact, I think, a little bit the way California structures its GHG reductions, because they really are looking at carbon drawdown. But the more carbon we have access to in that vine system, better for us. So we'll take a look at why it's a good idea to act now. And acting now is significant because this is a very first come, first serve situation. It's a rolling grant application. We'll get into that right here, right now. So it's kind of a get them while they're hot situation. The Healthy Soils program objective is to build soil carbon, reduce greenhouse gas emissions. The principles are going to be very familiar, especially for those who have been participating in the regenerative vines discussions we've been having since 2018, keeping the soil covered, minimizing disturbance, maximizing diversity, and maximizing plant life. The practices they're willing to fund are rife. There are 25 different practices. They almost all would apply in vineyard context. There is also an orchard component here. So a couple of those practices are orchard only. A couple of those practices are livestock and rangeland management only, but really at least 23 of them would work for us. And they really offer this year's funding in particular, because of its small changes that were made from last year. It offers leeway to generate a very reasonable successional strategy, so you don't have to try to implement everything immediately this year. The deadline is June 26th, but as you can see here, the fund began with $28 million this year, which is an avalanche of funding in this arena, and definitely a first. But those rolling applications have been coming in since April, and 10 million of that is gone. So there are very high rates of granting this year, which is great news for you if you can make use of it, because probably if you submit, you'll be farming with it, you'll be reimbursable. But you can see there the maximum award is $100,000. So that lets you know the level of participation that's going on this year. It's pretty high. So one thing to note, funding for these practices is granted to applications where these practices are not already being engaged on the land. Now that's not applicable to the totality of the vineyard. So if, for example, you have a separate vineyard block that's maybe it's currently farmed conventionally, hasn't even begun to transition away, but you have a block right next to it that's in transition and already has cover crops, that would not preclude you from applying for funding for any block that has a new practice going on this year. And that's another change that's happened just this grant cycle. So that's very interesting. So it's a little tricky, but not overwhelming, and very few limitations this year. And finally, the process. So the process itself, initially I was thinking it's 3 years start to finish. It may be closer just because of the finalized reporting to 4 years, but ostensibly you would make your plan in 2020, begin implementation with what's functional this year, then successionally move into what would work in 2021 and begin testing and recording the results in 2021, 22, and 23. And I think March, the end of March 2023 is the ambition for all finalized practices to have been established. But I have the impression at present, and I'll clarify this, I think the reporting component will go on until the final year, the 12-month phase after you've initiated your last practice. So that's the ongoing reporting component. And then down to the brass tacks of how you are remitted. There's a flat rate reimbursement for every verified practice. So ostensibly they'll reimburse you the moment that you evidence that you've got the practice in place, you've verified it's functional. And really, the thing that got me excited about doing this is that each of those 23 components outlined in the grant falls under one of the categories that you see noted here. So it's a really beautiful thing to dovetail regenerative practices, or say, for example, you have a vineyard that is CCOF now, and you'd like to either take it biodynamic, or you're interested in weaning it completely of any synthetic chemical application. Maybe you're beyond synthetics, maybe you're beyond systemics and you just want to move beyond synthetics. This is ideal for that. So here are the categories of funded elements. I'm going to let you peruse them, but again, you can see how beautifully they align with regenerative practices that we've been discussing in this group for quite some time. I'm just perusing them myself because I want to see if there's anything. Oh, so soil management practices, you can see there It's a little bit either or in a couple of the categories. For example, with compost, you're either going to purchase it or you're going to produce it on site. Either way, it will need to be tested. With residue and tillage management, you're either going to go no-till in that block or you're going to reduce tillage. Now, again, there can be differing blocks with differing approaches, so that's a non-issue and can be reimbursed regardless. But you're not going to do a combination of the two in each of these submitted categories. There's very little room for overlap in those categories. And then under the practices, some of these practices fall into separate groupings within categories. So you're not looking at funded groupings. There are a number of the practices for cover cropping, mulching, nutrient management, which is really just about reducing nitrogen fertilizers. Strip cropping, conservation, crop rotation, those guys are in, some of them are in separate groups. So you can be reimbursed for a multiplicity of those. And then skipping to the end, if you see the grazing lands notation, I was thinking, it's not going to be much in grazing lands that works for us, but we will focus on animal integration in the vineyard. And here, prescribed grazing is the terminology that the Healthy Soils program is using for that. So there is flat rate reimbursement there, and anyone who wants to discuss that with me can. Finally, I'll add too, the submission structure has its complexities. There are probably about 5 different reporting components, including the farm plan, that need to be submitted. And then a GHG study, so a greenhouse gas reduction study using the state's tool. Those are components that are valuable to know about upfront because they could get tricky and time consuming. And that's part of the reason I'm talking with you today, because I'm really interested in seeing as many people as can do this, do it. So I'm here to help. All right, let's move ourselves ahead. And if I encounter any technical glitches today, I'm just going to take a little time out. This is only the second time I've done a Zoom meeting, so cut me a little slack and we'll keep things moving. Let's look at some of the regenerative leaders before we go any further into the research and before we dive into specific reviews of the regenerative practices. These are some of the folks that are leading the way, particularly in things that are widely applicable to vineyard practice. Hey, Kelly, you can hear everything just fine, can't you? Give me a nod. All right, cool. So Mimi Castile spoke with us last February with Steve Mathiasen at the Regenerative Vines Coffee Talk. She is the owner of Hopewell Vineyard and formerly worked with the U.S. Forest Service as a firefighter. During that period of time, took her initial degrees and studies in history and began to apply them to the biochemistry of forest systems. And so I call her a biochemist BP by practice. And she is also the daughter of the Bethel Heights family in Oregon. So she had the opportunity of transitioning her family farm from organic practice to biodynamic practice, and then started her own vineyard working regeneratively. She is one of the most extraordinary voices, if any of you have heard her speak, that you could possibly hear in viticulture on this topic right now. Dr. Christine Jones is a soil ecologist out of Australia. She is a biochemist, and she has been has a very long career affiliation with a couple of universities there. But she works all over the world, and she focuses on cover cropping. She's truly a cover cropping specialist, so a microbiological focus in that arena. And it's we'll hear her voice in just a couple minutes. Right in the center, this is the key fellow we'll hear from today. Dr. David Johnson is a biochemist and researcher out of the University of New Mexico, Taos, but he has begun working with California State University, Chico, to develop their regenerative agriculture program. It's not a full teaching program at this stage. He's using this to leverage all of the research that he started in New Mexico and bring it to us and begin to establish some of that incredible work. Gabe Brown, I've really got him on here because he is a lifelong farmer, a tremendous sort of P.T. Barnum of regenerative agriculture, and he's the US poster boy for Dr. Christine Jones. He's been working with her for over 17 years. He transitioned his farm from cereals into livestock and mob grazing and polycropping and all of the components that you hear about but don't always see someone integrating. So Gabe and Mimi are fantastic people to watch for that kind of integration element. And then finally to the right, Dr. Vandana Shiva. Vandana is a Right Livelihood winner, the alternate Nobel Prize. She's based in India, but I have her on this set of influencers because she is so accessible in the US. She's here a couple of times a year lecturing, was just here in Santa Cruz recently, and she's the leader of the Navdanya seed saving movement out of India. Along with the people you see here, the true historic leaders that have prepared us for regenerative agriculture, Vandana is paired probably most familially here with Dr. Elaine Ingham, because Elaine and Vandana are celebrated the world over for suing Monsanto and winning. As a regenerative practitioner, I have to say that looking at the work of these two in the field of composting, in the field of heirloom seed, in the field of biology on the whole, we have them to thank for the topsoil that we have, and those lawsuits to thank for even being able to have this discussion. And of course, historically, we're looking at a time frame that takes us from the 1880s to the 1980s, when we first saw sustainability with the Brundtland Commission in 1987 coming to the fore, to now. So we've got Rudolf Steiner here. These are areas you're very familiar with, hopefully. And then other folks maybe you're not so familiar with, but Bill Mollison and Alan Savory. I love these two movements of permaculture for its ecological understanding, for its capacity to think in a design mechanism around how we farm within a forestry system. And then Alan Savory in holistic management for managed grazing, but also for farm planning. His strategic approaches to how regenerative farms can operate are extremely valuable. And then in the non-English speaking world, we've got incredible influencers that can't go unacknowledged. Miguel Altieri and Masanobu Fukuoka both have been people who work beyond the farming system and have looked at agriculture from the forested ecology in. And of course, that's no-till, non-intervention, and agroecology, where you're literally planting within the forest system from the outset and structuring your work by design to mimic that forest system. So you can see the alignment to the principles that we've been just flashing on the screen here. A number of the folks that are sitting in today are people that, I'm going to admit a couple more people here. So a number of the folks sitting in today are people who have been part of the Regenerative Vines conversation from the outset, so they are familiar with these. And I doubt seriously anyone who's here with me hasn't seen them before, but let's talk now about the practices themselves. So we're going to start with least disturbance. And each of these practices is being presented in the order you see it, because we're going to talk today about what is the ideal. Farming is never ideal, but the most reasonable adaptation of these practices to create the greatest possible benefit. So beginning with a phase out of synthetic and systemical chemical application and pairing that practice with the end of intensive cultivation. And this might not apply as you are designing and installing a new vineyard or as you're transitioning a vineyard, but eradicating disking, plowing, no bare earth policies. These are the first steps in creating restored aromatic amino acid function, which begins to percolate back through the vineyard system the moment that we have systemic chemicals like Roundup out of the picture. Synthetic chemicals further inhibit, and hence the fewer of them we're using, even in a CCOF organic environment, the better. And ending intensive cultivation, not only decreasing soil moisture evaporation, but creating some input savings as well, fuel savings, chemical purchase, and even the labor and tractor pass savings that are reinvested in time elsewhere at the transition phase. Got a couple new joiners. Hi, welcome everybody. So the next practice would be living roots. Now these living roots we're talking about starting with compost first, preferably compost that is a fungally dominant inoculated compost. And as that is spread, establishing gilded multi-species root mats. So species that function efficiently together as companions from the outset to support the system and ensure perennial subsurface support, providing nutrient access and mitigating pressures. And in that context, we're looking at the benefits of increased fertility, bioavailable nutrient, increased water holding capacity up to 7 times, increased tilth. So looking at tilth from that important perspective of not just providing more oxygen, water, and nutrient penetration, but thinking about tilth in relationship to its provision of, or how it's, think about how tilth occurs. Basically, you've got macro aggregate spaces, those great negative spaces being created in the soil by the waxes and other exudates, the glues of the microorganisms, that tiny 5% that is the living microorganism element inside the topsoil. And that's what not only aids in drainage, but stores that nutrient. And that's a very unique component that derives from cultivating a multiplicity of living roots, getting that root mat established. Increased soil organic carbon, not to be confused with soil organic matter. And that, of course, ultimately creates those long chain sequestering elements for soil. And then decreasing irrigation costs, erosion, compaction. All of these are benefits of increasing the living root system. And as below, so above, increasing soil armor is the next key element here. So you're focused here on selecting cover crop species that are staged to be perennial. In February, we heard from Steve Mathiasen talking about this and the way that he's seeding in grasses so that what shows up in the spring begins to die out. Late spring, we've got a late spring through summer cover that's going to require very little water and is highly drought resistant. And of course, into the winter, the stronger grasses coming in to revivify. And the same would apply across all of the cover crop components used in this system. So these are all supporting desired beneficial insects, but creating long-term habitat for those insects by establishing hedgerows, field borders, buffer strips. Long-term habitat for those creatures is part of the key set of benefits that we see, in this instance. And those benefits, gosh, a little technical element there. Let's see if I can move this 1 second. So clearly, increased pest and disease resistance, but balanced vine vigor. One of the key elements of cover cropping isn't so much to devigorate the system, but simply to balance the system. In other words, when you need devigoration, it happens, but it doesn't exceed your current necessity because you've created a balanced ecosystemic structure. That is a management component that you're leaving to the soil and can no longer be the central focus of your effort in this context of regenerative approaches. Soil erosion, of course, groundwater purification at the broader regional and ecosystemic level. We've got that, and we've got the benefit of increasing the water table over time. And then moving into animal integration, which is only appearing at this point in the process, because bringing animals in early, of course, is fine for fire issues and mitigation issues, and it's great to get that nutrient in the soil. But until you have a functional ecosystem that can truly create the explosive benefit of those animals being present and simultaneously provide a nutritive benefit to the animals that you're inviting in, it's best to hold off. And there are a number of people that will lecture to the challenges of doing that before you're really ready. Of course, that's a management component as well. But when there is fowl and forelegs combined in that environment, you've got an increase in nutrient content, of course, from the manure, but an increase in nutrient infiltration that doesn't require tractor passes. And hooves are incredibly elegant components of evolution, because an animal's weight through their hoof design is, in every case except the goats that you see here, distributed so evenly across the surface of the soil as not to disrupt those microaggregates and kill microorganisms. So every time that we get our systems to a point that they can support animal integration, it's definitely the thing to do. Reduce soil compaction, of course, and yet another increase in tilth is a benefit of this. And finally, it was really great hearing, and there are other anecdotal stories I've heard too, but hearing Mimi Castile talk about what happened in her Hopewell vineyard. They have about 20 acres, actually more than 20 acres under vine, but 20 available that she sells as a grower commercially. And she said the impact to their native flora was shocking when she had that multiplicity of micronutrient from the manuring of the pigs and the sheep and the chickens and the ducks that she brought in. So that's an element to consider, because that's what moves us into looking at ecosystems by design and beginning to have vineyards that mimic that design. Now, when we look at increased biodiversity, this actually gets a little bit more into the management of the human component of agriculture, because yes, we're focusing on two key elements here: introducing compost, so a set of fungally dominant microorganisms to jumpstart and reawaken the soil's capacity to support your vines, and then the 8-species cover crop, creating ongoing support and scientifically being evidenced now to create cooperation versus competition. But this also speaks to management. Biodiversity is maintained by making some shifts in the way we practice currently. So shifting to a high mowing, 4 inches, 5 inches or above, or even a rolling and crimping strategy. And rollers and crimpers are pricey little things. So a few growers I know are talking about cost sharing around issues like that. But at the outset, higher mowing. Why? Because grazers, for example, have it programmed into their DNA. If they're going to come back and wish to gain nutrient from that field again, they're going to stop eating about 4 inches so they can leave that living root mat alive but dormant beneath the soil. So they know they can cycle back through and get the same benefit. And of course, those root exudates that are so key to feeding your vines are definitely what's being kept alive by mowing to about 4 inches. So again, mimicking nature's approach and allowing insectary habit to self-seed. That's where you get into conversations with owners, winemakers sometimes, about the change in the look of the vineyard and our adaptation both to disease and pest tolerances. Steve Mathiasen has talked in many situations, but definitely in February spoke to us about powdery mildew tolerance and gave us a taste of one of his key wines that had 15% powdery mildew at harvest, and challenged us all to find that on the palate. I don't think anybody did. We had no major objections, but aesthetic qualities too. I mean, these are components that need to shift, hopefully will shift in the years ahead of us. And all of this leads to even more increased nutrient bioavailability. This happens again successionally over time. So this is why this part speaks to using our management strategies to continue to proliferate that biodiversity. And then one thing we haven't talked about yet, 24/7 nutrient availability. When we're not the ones deciding what to add and in what quantities, we're literally aiding our vines to the extent that if they need something at 3:45 a.m. and their root exudates evidence to the mycorrhizal structures around them, I need this nutrient paired with this soil mineral in this nutrient combination. They can get that at 3:45 a.m. on a Sunday morning, on a Monday morning, before any of us are there. This, to me, also reflects at a policy level, kind of a cap and trade, a carbon market, a carbon trading system that's happening beneath the soil. And when we have mycorrhizal functionality, when we've got those fungi creating those incredible hyphae around our root system, then we've got a trading market going on nonstop. So it's monitoring disease, pests, and pressures. It's monitoring water availability, and it's monitoring nutrient necessities and getting those nutrients into the root base. And then finally, increased in vine and wine balance. So over the long haul, we're looking at healthier vines, consistent yields, and beautiful wine in the glass. And this speaks a little bit to vineyard longevity. For that, I want to move ahead here. So here we have an amalgam of all of the practices and their benefits. And next we have simple review of the benefits. If anyone needs those slides, they'll be available to you. But before we move on, it's important to just touch on who are our communities? What are the real gains? And this relates again to moving forward with something like this grant. It's not only a benefit to farm this way for the quality of your wine, for the quality of the lives of those of us who work in wine. I mean, we have an opportunity here to mitigate cancer rates in our vineyard workers, to really focus on vineyard health as human health in the long haul. So our local communities, our global consumers have a healthier product in the glass and a healthier work life in terms of who's right here with us in the vines day in, day out. Local and state water districts, of course, are benefiting from regional watershed gains and numerous other components that aren't worth listing today. All biological species benefit from any increase we can give to the topsoil. We're being told now we have 57 years before we reach peak topsoil globally. We've been told we had 11 years last year, so we're in our 10-year and counting final decade before we hit a level of climate change that'll be beyond our control. But we see evidence, and with the climate science group here and atmospheric carbon reduction, we see evidence now from science suggesting that only 5% of arable land conversion with our farming crops worldwide, shifting to regenerative practices now could result in enough of a change to stop global warming from going over the top. So good to hear from those other communities and just be cognizant of the opportunity that faces us, even as we improve things for ourselves. And now we're just about to hear from Dr. David Johnson. So I want to focus on what's different about regenerative agriculture. A lot of these practices are extremely familiar. We've heard about them time and time again. We practice some of them in organics, plenty of them in biodynamics. So I really like emphasizing, and I hope you'll consider it this way, the evolutionary process of farming across the 8,000 years we've done it, especially related to wine, is evidenced by research that's finally showing us things we have never known about the soil, just as we don't know the breadth of operations, ecosystem services, and creatures that live beneath the oceans It's only now that we're finally finding out more and more and more about how these biologies work beneath our soil. And so there are two key differences to focus on here, and they are shifting agricultural soils from bacterial to fungally dominant mimics of forest ecosystems in terms of the biological life that's living in that topsoil, and doing that by using these 8 species or more cover crop systems that create cooperation versus competition in the soil. And one of the key researchers there is Dr. David Johnson. So I'm going to skip over in just a moment to his video. And first we'll hear from another voice and face I just want you to be able to see today, because I'm hoping you'll use the Regenerative Vines YouTube channel to check out some of these lectures. I'm convinced that anyone who would watch the lectures, there are about 6 or 7 of them on that channel right now, you will know more than 99% of the other farmers, viticulturists, almost anybody working in the business about regenerative structures and about current research. So it's really helpful to give those things a look. And then measurement. I thought it was valuable. I was able to attend an event with Sally Calhoun at Piscinus Ranch, which she manages down in the San Benito AVA. It has a 30-acre demonstration project, but 7,600 acres under holistic management with Kelly Mulville. And she says, the only couple of things we need to be able to measure to know that regenerative agriculture is a beneficial structure that's hard to mimic in other practices, and as evidence, we're evolving as we go, are these 2: soil organic carbon sequestered in that soil and increased water holding capacity, with up to that 7 times jump in what you've got sustained there for the course of your season. I saw a little note I meant to take off the screen for you. So yeah, we have an opportunity here to move from a silent spring to a regenerative spring. But what Sally has to say about all that is, if you show me any conventional farmer who has evidence that he has increased his water holding capacity up to 7 times, even 5 times, maybe even 4 times what he might have had historically, and he's sequestering carbon at significant rates that increase over time, I'll just tell him to keep farming exactly the way he's farming. But that's the tricky component, and that's the reward of beginning to make this shift. So with that, I'm going to make a little shift in screens here. And first, we're going to hear from Dr. Christine Jones. Christine is the microbiologist out of Australia, and I just want to give her a chance to give us a quick definition of soil. Let's see if I can make this go full screen, and hopefully the volume will be up for you.
So then we have to ask, okay, what is soil? We know now that it's weathered rock materials, and there'll be sand, silt and clay, or in your cases even like pumice and those kinds of things, but they have to have been in contact with plant roots. If you go somewhere in New Zealand where there are no plants, if it's too high, too cold, too dry, to go to the Sahara Desert in Africa, for example, and there's no plants, then you will never find soil. Anywhere in the world that there aren't plants and plant roots, you won't find topsoil. So as farmers, we have to be looking really closely at the plant roots. How deep are they? How many of them are there? What different kinds are there? And are they actively exuding energy into the soil to feed the microbes? And I think you'll see really clearly by the end of today how important plant roots are, and that's the main thing that you need to be looking at. And of course,
I'm going to pause her right here and shift to David.
the energy for those roots is going to come from the...
And that's going to take me just 1 second. Let's make her small. Here we go. And as David begins, this is going to be a chunky little segment. So really take your time with this. This segment answers the question, where's the science? What can I show to managers, to others in the vineyard context that will help convince them of the benefit of these strategies? This one focuses a great deal on the benefits of that fungally dominated compost element. So just FYI, enjoy, and there's more geekitude where this comes from.
Do it in a shorter time period. But what we got out of this product was a fungal dominant and biologically diverse compost. This came in very handy when we started doing plant tests to see how effective it was. But what we noticed first through the composting process was a change in the diversity. This is a 16S assay on the bacterial community of the composting process at 1 week. This is 22 weeks. This is when everybody says it's ready to go. So you can see the diversity has increased since that first week. And this is at 1 year. So you are increasing diversity in the system the longer you let it compost and the more you let it mature. So we use this compost to mimic what our soils look like. On the top left, you see a fungal bacterial ratio of 0.04. This is a low carbon soil, bacterial dominant, all the way up to a fungal dominant, 3.68 to 1, and a higher carbon percent. We were looking at how the carbon was partitioned into your root carbon, shoot carbon, fruit carbon, new soil carbon, your respiration carbon, and your total carbon that would go into nitrogen fixation. Now, carbon that goes into nitrogen fixation is very expensive to fix nitrogen. It takes about 12 units of carbon to fix 1 unit of nitrogen. You can see in a bacterial dominant soil, low carbon, only 3% of the carbon that plant captured went in to the plant. As you improve, as you increase the fungal to bacterial ratio and increase the soil carbon, we saw up to 56% of the carbon go into the plant. That's where we are in agriculture today. We are low carbon and we are bacterial dominant. So you have a choice. Which one would you rather farm on? Where do you want to put your energy? You want to be up in this range, so you're getting more return on the effort you're putting in. So in this process, we see an increase in net primary productivity. To give you a kind of an estimate of how things are on this planet, in the old growth forest or tropical forest, you see about 2,200 grams of dry biomass per square meter produced. In our cultivated land, the land that we fertilize, the land that we plow, the land that we irrigate, you see only about 600 grams of dry biomass per square meter produced. We're seeing with the application of this compost at about 400 pounds per acre, up to 2,200 grams increase in productivity, with potential of 3,186 grams of dry biomass per square meter, just by restoring the diversity of the microbes in the soil and changing that microbial structure from a bacterial dominant to a fungal dominant. This is the application rate we started with. It's about 400 pounds per acre. We only applied once at the beginning of this 7-year trial. And what we're doing is we're growing crops, cover crops, green chopping them, pushing them into the soil and growing another crop. We designed this experiment to see what kind of carbon rate, increase rate can we see in the soil when we dedicate all its energy that it captures back in. After 1 year of the beam application, it's a biologically enhanced agricultural management. You can see, compared to our control of a conventional field, that we see a 5 times increase in productivity. At year 7, we're up to 1,141 grams of dry biomass per square meter. So over this period of time, we've increased the productivity of this land 5 times. We did the desert plot just the opposite. We wanted to grow a cover crop, cut it, haul it off, and grow another one. We wanted to tax this system as much as possible. What we want to see is on both ends, if we put everything back and took everything off, where in the middle is that sweet spot where we can grow the crops we need and then improve the soil at the same time. The first season of this cover crop on the desert soil, we saw about 800 grams of dry biomass per square meter. This is the second season, that's 1,608 grams. You can see we've captured 486 pounds of nitrogen per acre on this plot at the rate the plant growth is. This is the third season. Each year, this thing has improved. We're seeing 2,190 grams of dry biomass per square meter at 583 pounds of nitrogen per acre. This is without any nutrient applications. This is just using biology from the compost that we make. This is what the winter cover crop biomass on the left. You can see the yellow is the control. The green is the treated with the compost. You can see the difference in increase. We started out with about 492 grams of dry biomass per square meter. Thank you. We're ended up over here at 3,186. Now remember, 2,200 grams is the most productive ecosystem on the planet. And yet we can see over 3,000 grams of dry biomass by improving the soil biology, increasing the diversity, and moving that from a bacterial dominant to fungal dominant system. You can see 777 pounds of nitrogen per acre was captured out of the atmosphere just with the biology. This is how we're being able to look at a soil now. You can see this is analysis of that particular experiment of the control and the compost. We're able to look now at the nitrogen fixation, both symbiotic and free living. We're able to look at nitrogen cycling. We're able to look at carbon cycling in this. And carbon cycling is really important because this is a living system. We need to realize that a certain amount of this is going to have to go into metabolism. A certain amount is going to be going into other organisms in the soil. We also look at metal oxidations. There's organisms in here that will mine any nutrient that plant needs. There's even some in here that can oxidize gold, the most stable element on this planet. Also see phosphorus solubilization, antibiotic and antimicrobial compound secretors. We see we see quorum sensing, and we also see CO2, carbon monoxide oxidation, degrading pesticides and xenobiotics, and also phytochemical production. If you're curious, this chart back here makes up about 195 species that have set the treated soil against the control. You can see all the different aspects of how microbes make this plant system work. We also looked at the metatranscriptome to see what proteins were being transcribed at the time. As you can see, quorum sensing was one of the highest. It was like 20 times higher than any other protein being transcribed in this process. Quorum sensing is when you get a community of organisms that get together, start to express genes that they don't express or can't express as a single organism. It's like when we, as a community, get together to make a change that one person can't make, but a whole community working together can.
All right. So that's David. And again, hello again. For geeks like me, that is total mic drop material. Now, by no means is my sharing this with you intended to act as the end-all be-all, proving the argument for these approaches. This is just the beginning of the insight into some of the science being conducted right now. These are legitimate funded studies and amazing and compelling results. So what we're really looking at here, and you know, when you see that increase in dry biomass, which is legitimate in yellow, that's what's been tracked in his trials. And then of course the red is projected over time based on what he's measured, not dissimilarly to how we would be measuring improvements over the first 3 years of implementation of the Healthy Soils Program grant. You look at this stuff and just think, it feels right now like sky's the limit. And at least this is a conversation that's valuable to have with all of the more scientifically driven decision makers in your organization. It really comes down to subcontracting the ecosystem services right beneath our feet for greater efficiency by design. And he has additional lectures, one of which was presented at COP21 in Paris on the YouTube channel for the Regenerative Vines Working Group. I'll send you a link to that, of course, where he talks really about this being the cumulative impact of layering practices in successive order to trigger these compound benefits, but it's all predicated on these earlier actions, those initiating actions around shifting to the fungal dominance of soil, which is not found in agricultural practice. We're heavily bacterially dominated soils. So at least once in any presentation, I just love to offer this image. It's so valuable to be reminded of the life that is suppressed with synthetic and chemical application and the life that can thrive without it. This is non-visible to the naked eye, but evidence of the mycorrhizal fungi in the soil around the actual nitrogen bead heavy root base of the plant you can see in this image. That's how hard the soil is working for you. This is a single-celled organism making all of that transitional dialogue happen between the nutrient exchanges existing in the living soil and what your plant needs at any given moment. Nice to take a look at, and nice also to think about key savings that come as a result of beginning to engage these kinds of practices. I'm listing, and I'm going to try to just keep it kind of short, a very high level analysis of all of this here, because it goes back to the grant structure and why California is so interested in investing. Regeneratively at a global level, there was a project conducted that took about 3 years to come to full culmination called Project Drawdown. It was published initially in 2013, and it listed the top 100 climate solutions that would eradicate the threat of runaway global warming. Regenerative agriculture practices came in number 11. And the key thing to note here is the investment to profit ratio. For an investment of $57 billion spread out over all global farms required to hit these projected goals, there would be an estimated return of $1.9 trillion through input savings in that same period of time. One of the things that people have asked me to explore is, how do I translate this to the CFO in my organization? How do I talk about the real savings over the long haul? And we're seeing, just in today's outline, the savings in operational inputs, the savings in vineyard maintenance, the savings in outside services and resource costs. But it was kind of exciting to me when Steve Mathiasen mentioned in our last coffee talk that he felt like Ted Hall had some good things to say about this, and that from a financial perspective, and as the owner of Long Meadow Ranch and an originating member of the McKinsey consulting organization, which I hadn't realized and was quite moved to learn, he said, Ted's got a corner on this. You should talk to him. So he put me in touch with Ted, and Ted said, sure, here's my argument. Use it with anybody you like, and I hope it helps. So here's what Ted said. First off, my approach is looking at the total farming costs over the life of that vineyard. And anybody I sit down and have a conversation with, I say, all right, tell me right now, what's the projected economic life of your vineyard? And conventionally, we know through examination that that's about a 17 to 20 year consistent yield. Organically, we know from CCOF and long-term studies, we're looking at the possibility with appropriate management of 30 to 35 years. Regeneratively, with what we're seeing from Dr. Christine Jones, Dr. David Johnson, and several others, I'm accruing a bibliography of white papers that I will share. We don't know. We don't know how long. And of course, we see vines that can yield tremendous productivity, even into the hundreds of years, with a multiplicity of management strategies. So that's not really an argument. But Ted's argument is, look at your total farming system costs. There's a point where the cost savings in a regenerative model exceed what you can do conventionally. And with the longer vineyard life, you're looking at a very significant payoff. And the final component he added to that was, while he was with a large wine company, and it's one that we all know and love and is beloved in California and across the world, he said, we did a 4-box analysis. We classified 40 vineyard managers, whether they were good or bad managers. And it didn't matter whether it was organic and conventional, so we kept that 50-50, half organic, half conventional vineyards. And then finally, we compared the total cost in each box. So it turned out that the bad vineyard managers were a higher cost whether they were organic or conventional. But that was a statistically significant comparison. Good organic managers and good conventional managers were very similar in outcome in terms of long-term costs, but organic results were slightly better. And with Ted's model and regenerative science coming to the fore, with good management, we don't know whether slightly better might become remarkably better as time goes by. So his end point is, so many of these anecdotes that debunk organic farming are taken from bad managers' results. And it's the management, stupid, not the farming, that matters. And that's the other thing that I think is so moving when I'm hearing people like Steve Mathiasen and Mimi Castile speaking about this work. Every one of them is saying, this isn't about doing something right or doing it wrong. It's about evolving to what's most efficient, what's most productive, what gives you the greatest longevity, and what's going to work most ideally to keep our ecosystems serving our vineyard systems in the long haul. So I was excited to have Ted weigh in, and I thought you might find that beneficial to think over for today. So as we start to wrap up, there is a rolling grant submission, hence those grants are being snapped up pretty quickly. What I've decided I'd like to do in regards to my own skill set and contribution here, and I didn't really go into that, but since 2006, I have worked in sustainability. I was on the island of Manhattan for 20 years of that time frame, working both in wine and sustainability. On the sustainability side, though, I wrote and won a number of grants, particularly during the heyday of the green movement, energy efficiency pairing with renewables in the built environment. That was about 2008, 2009, 2010. I mention that because I didn't just cut my teeth on writing and winning grants at that point. The confluence of components that came together in that moment in New York City is very similar to what's happened in California for this grant cycle with Healthy Soils. Gavin Newsom agreed to a $28 million grant fund this year. Next year, he's already halved it. What Renata Brillinger and other people at CalCan and beyond are trying to get him to do is to commit to $18 million every year for the next 5 years so that we can get more and more farming environments online to be doing this kind of carbon drawdown. But I haven't seen that kind of structure of the grant and these kinds of practices being yielded from a very new science in agriculture come together in this way since the early 2000s. So anybody who wants to take advantage of this, this is the 10th, this is our next webinar. So I'll leave this recording in your inbox. You can share it with anybody you'd like. What I'd like to do is offer my grant writing services. I've set up Vineyard Walks and already done a number of them with people who want to move on this and go ahead and get their grant submitted. And instead of charging a full grant writing fee for this, I'd like to work with people on a sliding scale for this particular year. The more this money gets used, not only the more vineyards get transitioned, but the greater the chance that we'll convince Governor Newsom to keep doing it and to make that connection between soil health, ag practices, and human health in the state of California. So anybody who's interested should reach out to me now. I've got time Monday, Wednesday, and Thursday of next week. And those who want to take next steps should hopefully have me over and we can just talk through it, see whether it makes sense for you to do. And then I'm going to figure out through the end of April what kind of fee structure I would offer each group so that the majority, I can do about 5 of these and offer oversight. And I'm in conversation with Keith Abellis. He has been appointed, he's out of the Sonoma RCD, and he's been appointed as the technical support fellow who's going to do all the sign off on the final designs and recommendations for submissions to the grant. I met him yesterday. We had a really good exchange and he said, this is amazing that you can even get your head around this right now because he doesn't really have time to dive into it till May. So anybody who wants to get a head start now can start with me. I'll interface with Keith and we're going to work really closely among all of the RCDs to make sure we get everybody in who can be. So yeah, that's my little pitch for get it while it's hot. And finally, you've got my email address there, my cell number. I am only ever a DM away. Just shoot me any communication you need. I will send you a follow-up link. I liked the fact that you submitted that research question, Brent. I'm going to take a look over the weekend and see which papers I can share with you right now and try to really give some time to that. So Monday, I'll follow up with a link. It'll contain the Regenerative Vines YouTube channel, but of course you can just go to YouTube and find that there now. I've got a set of Google Docs for the working group. And the big thing there is a really nice little spreadsheet that has the SWEEP program, the HSP program, all of the links that let you take a look at what's available. So I can let anybody who's not in on that right now have a little access on Monday. And long and short, the Regenerative Vines Working Group is really here to facilitate as much of this as we can possibly do in the grant cycle in a short period of time. So if you need help ramping up, use the group and reach out to me with anything that I can help you with, because that's why I'm here. So thank you. Thanks so much for spending the time. And we're just a couple minutes over. I'm going to let you go, have a beer, relax after your incredible accomplishments this weekend. And lastly, just thanks for being interested, because this is definitely a time when we're all called to do as much as we can possibly do to get that soil health and human health component connected. All right, I'm going to end the meeting. Enjoy, and we'll take it up one-on-one.
Thank you, Janna.
You're welcome.